Methods, Part 1. This is the first of 3 videos. What is a method? A method is a group of code that can be called to perform a task. As a side note, these tasks are usually fairly simple. And one of the big benefits of a method is you might call it lots of times in your program so you don't have to rewrite that code. But we're writing pretty small, simple programs, so it's going to be fairly often that we write a method we only call once while we're learning. Benefits of a method: readability and procedural abstraction. The name of a method will tell you what it does without requiring you to analyze its code. So when we see the method math.pow, we're like, oh yeah, that does a power. You might wonder, how does it do it? And you're like, based on the code I know, I don't know how to do a power. So you might not know how the code in that method works, but you don't have to. By reading the name, you can understand what it does, and that's procedural abstraction. You don't have to know what the code is and how it accomplishes it. You just need to know how to use the method so it will perform that task for you. Kind of like system.out.print. Print is a method. How does it get it to the console? Who knows? But it does it, and it's cool, and we're happy. Maintainability. The code for a task is kept in one place rather than being written multiple times throughout your program. So if you had to do some code to calculate someone's tax rate, and let's say in your program you have to do that 5 times. So you write that code and you copy and paste it 5 times. Then you figure out the code you wrote is slightly wrong. It doesn't really work. You would have to go change it in all 5 spots. If you only changed it in 4 spots, your program would work most of the time, but not really all the time, and you would have thought you fixed it in all 5, and then it just runs into this huge issue of trying to figure out where you messed stuff up, and all that extra work of changing messed up code in multiple places. If you write code in a method, it's kept in one place. If it's wrong, you fix it in one place. Method signature. So it says it down here, but up here where it says, can't highlight. Public static return type method name parameters. This is the format of what a method's going to look like. And that very top line of a method, that is the method signature. The curly braces, the code inside, the other curly brace, that's going to be your body of the method, but the method signature is that top line. And it will include the method name, a name that describes what your method does. Parameters, data your method needs in order to complete its task. The type/name of the parameters listed in the method signature is known as the formal parameters. You're listing off what type of data you want and what you're going to call that data when it gets there. The values you send to the method are the actual parameters. Return type, the type of data the method gives back. Use void for methods that do not return data. So if you had a method that adds 2 numbers, you might send it an int and an int, and the result that you expect it to give you back would probably be an int, which is the sum of those 2 numbers. Parameters. Do we need them? Variables only exist in the method they were created. So you do need them. So if you create stuff in main, you've gathered them from the user, down in some other method, a different portion of your code, the variables will not exist down there. So you do need the parameters. You need a way to pass that data from your main method or some other method to a secondary method. And how you do that is through the parameter list. So you do need parameters. You can't just leave them blank and then access the variables that are outside of the method. Does the parameter order matter? Yes! You can get compilation or syntax errors, logic errors, and runtime errors when the data is sent incorrectly to a method. So if you send the data in the wrong order, you could be causing all kinds of problems. If you send a double then an int, and it wanted an int then a double, it's going to try to match the double to the int, and it won't be happy, so it won't be able to call the method. If you sent two things in the wrong order, and let's say it was x and y, and you're supposed to divide y by x, but you send y then x, then the x is the y and the y is the x, and you're dividing the wrong thing by another. With that's a logic error. You'd get the wrong output. But let's say you were supposed to divide x by y, and it was supposed to be 0 divided by 3. If you in fact did 3 divided by 0, your program would crash with a runtime error because you can't divide by 0. So you can get all kinds of errors if you send stuff in the wrong order. So you have to pay particular attention to the order they have to be sent. Return command. Once a method has calculated an answer, it can end the method and give the result back with the return command. The format for returning a value is return whatever value you want to return. Now, note that when you return a value, the method is done. It cannot execute any further lines below the return because return will kill the method and return the value. Any code beyond the return statement will not be accessed. Void methods do not require a return statement, which we'll get to later. But sometimes you want to end a void method without going all the way to the end of it. If you do return semicolon, you won't return anything, but it can kill a void method. Adding method. So we're going to go over an example here. Public static int add int a int b. So let me get the pen out. Right here, this is where the return type goes. This is saying I plan to give you a result that is an int. My name is add. That is a description of what I do. I want from you an int value. I will call it a. I want a second int value. I will call it b. So in this method, a and b will exist because we define them in the parameter list. It doesn't matter what they're called in some other method. The values that come here will be called a and b. Int sum, a new variable, equals a plus b. When I'm done, return the value that is in sum. And that is an add method. We'll see some examples in my next video where I actually have a main and I call method and walk you through the entire process. Method overloading. Method overloading is when you have two methods with the same name. That's kind of weird. But they have a different parameter list and possibly a different return type. Overloaded add method. So we just had add in the previous one. But this one says, I'm going to return a double. If you send me a double and a double, I will produce a double answer for you. And my name is add because I'm adding. So you can have a method called add that receives an int and int, and you could make a second method with the exact same name that receives a different list of items, and the computer will figure out which one to run based on the type of data you're sending to the method. So here it's the same code, but it's working with different types. So it's a double sum, and we return the double sum. Calling and invoking a method. How you call a method is method name, parenthesis, parameters, semicolon. Calling a method and storing its returned value. Some methods return a value, like the add method we were just looking at. Variable name equals method name, parenthesis, parameters, parenthesis, semicolon. This means invoke the method. When it figures out an answer and return it, I will put that answer into the container on the left side of the equation. By reference and by value. Values are sent to methods either by value or by reference. By value, the method will receive a copy of the value. Note that all primitives are sent by value. Changing the value of a received variable in a method will not change the value of the original variable that was passed to the method because you are sending it by value. If x is 8 and I send x to a method, I'm not actually sending x, I'm sending 8. Even if the method receives it into a container called x, that is a different container than the container in main because we are outside of main. So we pass the value x to the method. If we change x to 7, that would not affect the x that's in main because we passed a copy of x. We passed the value 8. By reference, the method receives a memory address of the original variable and uses that address to access the original variable. So here, if you were sending something to a variable, you are sending where that data lives. So if you receive where some data lives, if you go to that location of where the data lives and changes it, and you make a change to it, when you get back to main, the original variable is affected because you didn't send its value, you sent where to find that variable. Changing the value of a received variable in a method will change the value of the original variable that was passed in this method call, and that is by reference. Now, we're not actually going to see this in practice because strings, let me go to the next slide, string behavior. Strings are passed by reference. If on a test I ask you, are strings passed by reference or by value? Your answer is they are passed by reference because all objects and arrays, which we haven't covered much about objects or arrays yet, so this will make more sense in the future, are passed by reference, meaning if you change them, you affect the original. But strings have a unique behavior, which we'll get to more when we cover strings. But because of how strings behave, even though they are passed by reference, they work like they're by value. And you just have to remember that strings are passed by reference, but it's not actually going to change the original if you change it. And that's based on their unique behavior, which we'll get into when we get to the strings chapter. All right, that concludes our first video. We have a lot more examples in the next video, so hopefully things will start making a little more sense.